A car speeds down the road. Its engine is not sending power to the wheels through a drive shaft. There is no differential, no driven axle. What actually pushes it forward is a high-speed propeller, spinning like the one on an airplane. It sounds like science fiction, but in the 20th century, people really did build cars like this. Some appeared on racetracks and became spectacle machines. Some entered military thinking and were tested for crossing sand and snow. Others were seriously intended to become practical cars for wider use. They look like airplanes on the road, flying machines forced to stay on the ground. The question is, if a propeller can drive an airplane, why not a car? Was this idea an underrated vision of the future, or a technological dead end from the very beginning? This is the story of speed, imagination, and humanity's attempt to translate the language of the sky onto the road. Propeller cars did not emerge naturally from within the evolution of the conventional automobile. Their starting point lay in the aviation boom of the first decade of the 20th century. At that time, airplanes were still far from mature, and airships still held enormous imaginative appeal. Lightweight gasoline engines, wooden propellers, belt drives, chain drives, and makeshift test grounds together defined the technological frontier of the era. In that context, the propeller was not just a component, it represented an entirely new way of creating motion. One of the earliest known examples was the Curtiss wind wagon around 1906. It was associated with Glenn Curtiss and with airship propulsion testing. Its main purpose was not to serve as a car in the ordinary sense, but as a ground-based propulsion test vehicle. Its basic logic was already clear. Instead of sending power to the drive wheels, the engine drove a propeller directly through belts and reduction gearing. The wheels carried the load, but the actual thrust came from air accelerated backward by the propeller. Curtiss described the machine in very direct terms. It had no commercial value, but it could run, reaching about 30 miles per hour. At the same time, it frightened horses, raised clouds of dust, and could even blow all the leaves off low branches along the road. That already reveals a defining feature of the propeller car from the very beginning. It did not simply use a different drive system, it actively altered the environment around it. Noise, airflow, and dust all came with it. Around 1908 to 1909, Morris Park in the Bronx, New York, became one of the important sites of early aviation testing. It hosted not only airplanes and airships, but also various propeller-driven ground machines. One of the more representative examples was Dr. Thomas's wind wagon. It was among the earliest four-wheeled propeller cars to enter public view. Its designer, Julian P. Thomas, was a typical early technical adventurer, involved in aviation, fascinated by mechanical experiments, and frequently associated with accidents. In one 1908 test, he was seriously injured in a wind wagon accident. By 1909, the machine was already being shown in public demonstrations, driven by Charles M. Kraut, and the press described it as delivering a surprisingly fast performance. These machines also exposed a problem very early on. They were often not designed around the full operating conditions of a ground vehicle. They were more like engines and propellers that had simply been mounted onto a set of wheels. For inventors of the time, that way of thinking was not hard to understand. The automobile industry itself was still experimental, and gearboxes, clutches, drive shafts, and differentials were nowhere near the level of maturity they would later reach. Driving air directly with the engine could actually seem like the simpler solution. But the problems appeared quickly. A propeller is not especially good at getting a vehicle moving from a standstill. It usually needs the vehicle to already be in motion before its efficiency enters a more favorable range. Yet the moment a car needs power most is exactly when it is first setting off. That made early propeller cars easy to find impressive on test grounds, at demonstrations, and on open roads, while making them much harder to justify as practical vehicles for everyday road use. In 1910, this demonstrative quality was amplified even further. The Overland propeller car appeared at an aviation event at the Indianapolis track. It was a modified Overland automobile fitted with a propeller about 8 feet in diameter, and reports placed its speed at around 53 miles per hour. Its significance did not lie in proving that propeller cars were more advanced, but in showing that by around 1910, simply making a car look like an airplane already had strong promotional value. The same trend appeared in Britain as well. Around 1911, the ABC propeller test car appeared at Brooklands. This machine is especially important because it makes the original identity of the propeller car even clearer. It was not built to become a civilian means of transport, but to test airplane propellers. By this point, the early form of the propeller car is already clear. It did not grow naturally out of the conventional automobile path, but was an extension of aviation propulsion technology onto the ground. Although these early machines differed greatly in appearance, their core logic was the same, using a propeller rather than drive wheels to provide propulsion. From here, people began to seriously consider whether this idea could move into more practical settings. By the 1910s, propeller cars began, for the first time, to approach something like a practical use. The reason was simple. On ordinary roads, they were hard to justify as more efficient than conventional automobiles, but on sand, mud, and other soft surfaces, the situation changed. A conventional vehicle depends on traction between its driven wheels and the ground. Once the surface becomes too loose, the wheels easily spin without moving the vehicle forward. Propeller propulsion works differently. It does not transmit power to the ground through the tires, but pushes air directly backward, which in theory makes it better suited to low-traction terrain. That is why propeller cars quickly became associated with desert travel. One of the most representative machines of this stage was the French military cross prop car, also known as sauterelle, or grasshopper. It appeared around 1912, and its purpose was not road transport, but movement across the sandy terrain of French North Africa. This was no longer simply a car with a propeller attached. It used a multi-wheel layout with rear wheels adapted to uneven ground, and some versions even used doubled tires. The purpose was clear: reduce ground pressure and lower the risk of getting stuck. At the same time, the main task of propulsion was handed to the propeller in order to bypass the problem of driven wheels spinning uselessly in sand. More importantly, this vehicle was actually tested in desert conditions. It was not just a paper concept, but a real machine taken out into the field. But its problems were just as obvious. A propeller could provide thrust, but it could not replace tires when it came to steering and braking. And in sandy terrain, a high-speed propeller would throw up huge amounts of dust, exposing the vehicle's position and reducing the durability of the machinery itself. So this approach was not entirely irrational, but it was too narrowly focused on one part of the problem. It could reduce the issue of driven wheels spinning in place, but it could not solve the full set of problems a ground vehicle had to deal with. Machines similar in concept included Lafargue's French military prop car and Britain's 1915 Césaire-Berwick wind wagon. Their logic was essentially the same. In low-traction environments such as sand, snow, or mud, air propulsion might compensate for the weaknesses of conventional vehicles. But none of them ever became practical. That shows something important. Propeller cars did have more value as an idea in extreme terrain than they did on ordinary roads. But even there, they still fell short of becoming a mature solution. At the same time, the route itself was beginning to change. It was no longer aimed only at experiments in special environments. It was gradually being redirected towards something else: the attempt to redesign it as a true personal vehicle. By the late 1910s, this line of development finally found a truly important figure, Marcel Leyat. What he wanted to build was no longer a desert test machine or a demonstration vehicle. What he wanted was a genuine personal vehicle, something that could actually be sold and used. That is why, among all propeller cars, the Helica holds such a special place. Leyat came from an aviation background, and that shaped his thinking in a way very different from conventional automobile engineers. In his view, one of the main problems with the automobile was that it had become too heavy, too complicated, and too dependent on a whole chain of transmission components. The engine, clutch, gearbox, drive shaft, and differential all added weight and increased mechanical losses. His idea was very direct. If an airplane could rely on a light structure and a propeller for propulsion, then a car should be able to do the same. The body should be as light as possible, the structure as simple as possible, and power should go straight to the propeller, minimizing intermediate transmission losses. Visually, the Helica also looked nothing like the mainstream automobiles of its time. It resembled a small aircraft running along the ground. Early Helicas were usually three-wheeled, two-seater machines with a long, narrow body, an engine at the front, and a propeller mounted ahead of it. The earliest versions barely had any real protection at all, with the propeller fully exposed at the front of the vehicle. That already shows something fundamental. Although the Helica was more complete than the earlier propeller cars, it still inherited the deepest danger built into the whole concept. Later versions added wooden shrouds, metal mesh, and more complete bodywork, which shows that Leyat was not unaware of the safety issue. He was not simply chasing an eccentric shape, he was trying to push this idea step by step towards something usable. This point is crucial. The biggest difference between the Helica and the earlier wind wagons is exactly this. It was not a temporary test platform, but a genuinely evolving series of vehicles. From 1913 to the mid-1920s, Leyat continued to develop the Helica, producing multiple versions over time. Sources usually place total production in the range of several dozen vehicles, with the most common figure being close to 30. For a technological path that never became mainstream, that was far beyond the scale of a one-off experiment. In other words, Leyat made a serious attempt to turn it into a real product.
From a technical point of view, the advantages of the Helica are not hard to understand. First, it was light. Compared with many conventional cars of its time, that lightness alone could already translate into respectable speed. Second, its mechanical layout was relatively direct. Without the complex power transmission system of a conventional automobile, engine output went more directly into propulsion. Third, its performance was not just a fantasy on paper. Surviving records show that a 1921 Helica could reportedly reach about 70 kilometers per hour quite quickly, while a still-running 1922 Helica has been recorded at a top speed of about 60 miles per hour. But the Helica's problems were just as clear. The most fundamental was safety. Whether or not it had a protective shroud, a large, high-speed propeller mounted at the front of the vehicle was inherently at odds with public road use. That was not a minor flaw, but the deepest structural problem of the entire concept. Then there was the user experience. The vehicle might have been light, but its airflow, noise, vibration, and driving feel were all very different from those of a conventional car. It was not simply a simpler automobile, it was more like a completely different kind of ground machine. And beyond that was the broader reality. The automobile industry of the time was developing rapidly. Conventional engines, gearboxes, chassis, and tires were all improving, while mass production capabilities were expanding as well. In that context, the Helica may have had distinctive advantages, but once it faced real market competition, it was ultimately not accepted. As conventional cars advanced quickly in engine design, transmission systems, and mass production, the Helica's path lost any room left for expansion. The Helica did not change the direction of automotive history, but it remains one of the most famous and most representative unconventional vehicles in that history. By the 1920s and 1930s, propeller cars had largely dropped out of the competition to become everyday vehicles, but they did not disappear. Instead, they survived in another form. Inventors' experimental cars, magazine concepts, home-built machines, and a small number of more complete prototypes. The character of this stage is clear. It was no longer a stable line of technological development, but a series of recurring, loosely related attempts, similar in spirit, yet mostly unable to develop much further. One typical example was Spencer Heath's test vehicle. Used in 1922 to test a variable pitch propeller, its importance lay not so much in the vehicle itself, but in what it represented. By this stage, propeller cars were still closely tied to aviation propulsion experiments. For some engineers, a ground vehicle was still a convenient platform for testing propulsion systems. Another, more typical category was the wind wagon, promoted through hobbyists and popular mechanics magazines. A good example is the Jameson wind wagon. It first appeared in publications such as The Boy Mechanic, aimed at mechanically minded readers, and was later actually built by enthusiasts. The characteristics of these cars were clear. Simple structure, small size, readily available engines, straightforward chassis designs, and an obvious handmade personal invention quality. This shows that by this stage, propeller cars had increasingly become a subject for mechanical hobbyists rather than something that still looked likely to enter the industrial mainstream.
A good example is the Helicron of the 1930s. Based on a conventional chassis, it had a more finished body and looked closer to a proper vehicle rather than a bare mechanical experiment. That shows that even at this stage, some people were still trying to make the propeller car look and function more like a real automobile. There were also more conceptual designs, such as the sewn vane car. It was no longer satisfied with the conventional propeller layout, but instead tried to reorganize propulsion through fans and guide vanes. Most of these ideas remained on paper, in illustrations or at the concept stage, but they represent the mindset of the era very well, not abandoning the route, but constantly trying to repair its weaknesses through new configurations. Yet in the end, propeller cars never developed into a stable direction. By this stage, they had become a series of scattered but persistent attempts. By the 1930s, the propeller car idea began to merge with another major technological trend, aerodynamics. Many early propeller cars had simply combined an engine, a chassis, and a propeller in the most direct possible way. But as streamlined design became more important, the question changed. If a vehicle already depended on air for propulsion, should its entire body also be shaped to obey the air as much as possible? One of the most extreme examples of this stage was the Schlorwagen. Originally, the Schlorwagen was not a propeller car at all. It began as a highly streamlined experimental car built around one goal above all others: extremely low aerodynamic drag. Its body was shaped almost like a fully enclosed teardrop. Its most famous feature was its remarkably low drag coefficient. The importance of the vehicle lies not simply in its strange appearance, but in the way it pushed a question to the limit. If the automobile became increasingly shaped by concerns about air resistance, would it eventually start to look more like an aircraft than a traditional car? It was at this point that modified versions appeared with an aircraft engine and fan propulsion. Only then did its connection to the history of propeller cars become fully established. This step was important because it showed that by this stage, propeller cars were no longer merely inventors' curiosities, but had begun to connect with more serious aerodynamic experimentation. But the Schlorwagen also revealed another problem with the whole route. Even if the body had been pushed to an extreme of streamlining, even if its aerodynamic quality was far beyond that of the early wind wagons, that still did not solve the basic realities of being a road vehicle. Low drag could improve speed and efficiency, but it could not automatically solve safety, control, or real-world road adaptability. By this point, the issue was already very clear. Propeller cars were not something nobody took seriously, nor were they something nobody kept trying to improve. From the earliest wind wagons to desert and military concepts, from the Helica as a product line that came closest to everyday use, to the more extreme aerodynamic and aviation propulsion experiments of the 1930s, this route had been tested again and again, and yet it never became the future. First, it was never well suited to real road environments. Propeller propulsion may look straightforward, but a road vehicle needs more than the ability to move forward. It must also be safe, controllable, durable, and capable of functioning among pedestrians, obstacles, narrow roads, difficult surfaces, and long-term daily use. A large, exposed propeller spinning at high speed was fundamentally at odds with that environment from the very beginning. Second, its advantages were too limited. On sand, snow, mud, and other low-traction surfaces, air propulsion could indeed avoid the problem of driven wheels spinning in place, but that was only one part of the vehicle problem. Steering, braking, stability, safety, maintenance, and road adaptability were not automatically solved by adding a propeller. In other words, it solved one narrow problem while introducing a whole new set of complications. Third, conventional automobiles improved faster and more comprehensively. Propeller cars kept evolving, but ordinary cars were evolving too. Engines became more reliable, gearboxes more mature, tires, suspension, chassis, and braking systems all improved, while mass production and road infrastructure advanced at the same time. Under those conditions, it was not that propeller cars had no distinctive qualities, but that those qualities were not enough to outweigh their disadvantages. Even so, the route never completely came to an end.
The 1955 Robbins prop car represents another post-war continuation of the civilian propeller car idea in Britain. It was a three-wheeled propeller car with a propeller about 3 feet in diameter mounted at the rear, powered by a V4 engine of around 15 horsepower. Some sources even claim that this engine was made by cutting a Ford V8 in half. It is said to have cost about £200 to build, taken 6 months to complete, reached a top speed of 70 miles per hour, and delivered fuel economy of about 60 mpg. The Argentine Aerocar of 1955 still attempted to combine propeller propulsion with a more complete automobile body. It showed that even in the post-war period, some people still believed this idea might find a new chance through more mature vehicle design. The Brazilian FE1 X1 of 1968 carried the same line of thought even further into a later era. By then, propeller cars could no longer compete with the mainstream automobile industry, but they still survived as engineering concepts and exhibition pieces. As for the Stuttgart Ventomobile of 2008, it was no longer a propeller car in the traditional sense. The large propeller on its body was actually a wind turbine, extracting energy from the wind in order to drive the rear wheels. Propeller cars may have been left behind by history, but the direction they pointed toward never truly disappeared. What they were really trying to do was step outside the existing logic of road transportation and redefine, in another way, how a vehicle moves forward. Today's flying cars, EV tolls, and various forms of personal air mobility are, in essence, still trying to answer the same question. The difference is that 100 years ago, people wanted cars to borrow the propulsion of airplanes. Today, they want cars to leave the ground altogether. In that sense, the propeller car was not an endpoint, but something closer to a rehearsal that arrived too early. This is BHE, Brief History of Everything.